Hi all, welcome to Kothad channel. In this video, I'm going to explain how to build a model to recognize the human emotions from images. Let's dive into the demo first. So here is the final project, how it looks, human emotion recognition. Okay, here it takes the path. Okay, and here it is going to say that the kind of emotion inside the image, and here we are displaying the image as well. Okay, if you see here, there is a folder called Google Images where we have downloaded a couple of images from the Google, and the name of the image says that the kind of emotion inside the image. Here we have four images. One is angry, happy, sad, and surprised. And let's see how this model is going to predict the emotions, whether it is predicting properly or not. So first one is angry. Let's copy it as a path and then pass it here. Okay, and remove this double quotes. Home and delete, press enter. So it's angry. And next one is happy. Yeah, emotion is happy. And what else the next one? Sad. Okay, pass sad. Oh, sad. Emotion and the image is sad. Okay, it's predicting properly. Surprise. Surprise. Treating it as an angry, okay, because it seems like they're shouting, right? So that's the reason it is thinking it as an angry. So out of four images, I think our model has been predicted one image wrong and remaining three it's predicting properly. This is how our final project looks like. First things first, to prepare face emotion recognition CNN model, we would need the images dataset with the classification of emotions. So once the dataset is ready, we will be loading it into arrays to feed it to the model. And next step is creating a sequential model with the multiple Keras layers. So once our model is ready with the multiple Keras layers, then we will be feeding the images dataset to this model. So once our model is trained and then validated with the validation dataset, then our model is ready to predict the new values. So once our model is able to predict the values properly, then we will be saving our model and we will be deploying it as a web application, as you guys have seen the earlier part of this video. Let's dive into the coding. Let me name it as image, sorry, human emotion classification. Okay, done. Okay, now before going to the coding, I would like to show you the dataset. You see here there is a folder called facial images. Inside it is having two datasets. One is training dataset and another one is the validation dataset. So inside training dataset we have the 7 different folders: angry, disgust, fear, happy, neutral, sad, and surprise. Okay, and inside these folders we will be having the images related to that particular human emotion. Okay, and similar to the validation dataset as well, we are having all these emotions folders, and then inside of these folders we'll be having the images respected to that. Okay, now let's move into the coding. Let's import the necessary libraries. Okay, go to terminal and type in pip install. We need matplotlib to draw the images from the folders. That is the first thing. And second one is we need the TensorFlow Keras, and third one we need is NumPy. Okay, and fourth one is CV2 to read the images from the test images, okay, from the folders. I think these are the libraries that we would need, and finally we would need Streamlit to deploy it as a web application. Okay, and when you are using this Jupyter Lab, you can directly type in here. Otherwise you can go open command prompt and type in here pip install, same thing. Okay, and these libraries will get installed in your system. Okay, I already have installed these systems in my laptop, so I'm not going to install them again. Okay, I'm just going to import those libraries. Okay, so let's import the necessary libraries. Okay, import numpy as np, import matplotlib.pyplot as plot, import TensorFlow as tf, and import TensorFlow dot keras dot preprocessing dot image. Okay, removing them. Import image data generator and load image. Okay, from TensorFlow dot keras import layers and models. Okay, I think we should be good now. Okay, once we have imported the necessary libraries, let's import the training dataset and validation dataset. Okay, let's create variables for these folders. Okay, training data path is equals to, okay, copy path, okay, same, train validation path, data path. Okay, instead of train, it's validation. Okay, now let's check it out how many folders are there. Okay, how many expressions are there. Okay, for expression in, we need the OS as well, right? Variable. Let me import that as well. Import OS. Okay, for expression in OS dot list directory, and we need train data path. Okay, print expression. So we have angry, disgust, fear, happy, neutral, sad, surprise. 1 2 3 4 5 6 7 7 different types of expressions are there, human emotions are there. Okay, now let's see how many images are there in each and with respect to these emotions. Okay, and for that one, what I'm going to do is print expression comma space comma yes start list directory trying data path plus expression. We need to add expression. Okay, and length of this one would give us the number of files inside these folders. Okay, let me add here. Okay, see, angry we have 3.9k, disgusting 436, just fear 4.1k, happy 7.1k, neutral 4.9k, sad 4.9k, and surprise is 3.2k. Let's print how many images are there. Okay, total images. Let's take it as x is equals to 0 and end x is equals to x plus let's copy this count. Okay, and print total images. Okay, x. Okay, here we have 28k images are there, total images. Okay, from all the human emotions from the training data set. So let's copy it and just check it out for the test data set as well, validation data set, validation data path. I'm just changing the path here. Yeah, here also we have 7k. Okay, here we have 7k images. Okay, angry 960, disgust 111, fear 1018, happy, neutral, sad, and surprise. So we have all these emotions. Let me do one thing. Let's take all these emotions into a one array. Okay, let's take one dummy array. Emotions is equals to dummy array. Once we have this here, data is equals to expression. Okay, and end emotions dot append of data. Okay, it's it's done. Now let's print emotions. Yeah, here we have angry, disgust, fear, happy, neutral, sad, and surprise. Okay, fine. Now we have taken these categories into these emotions. Okay, now what I'm going to do is, yeah, now we have taken the category. Now what I'm going to do is, let's print some images. Okay, uh, I is equals to 1. Okay, let's print 7 images from 7 different emotions. Okay, from for expression mm, for expression in OS start list directory, and let's take training data set. Okay, training data path. Okay, image is equals to um, OS start list directory of training data path with addition inside subfolder with the expression, right? Plus expression, and for this one what we are going to do is, okay, and let's take the first image. Okay, let me print this image first to see whether it is working fine or not. os.list directory plus expression. Let's pause it on to do load image, and then it will work, I guess. Load image of this one. Okay, here, okay, let's do it. We don't need this one, right? It's already there. And here, copy these two first, concatenate these two parts, then we are adding another. Now it should work, I guess. Yeah, now it is working fine. Okay, so we have the image. Now plot that image show of this image, and let's have this map plotted, right? Plot dot figure of, okay, figure of fixed size, right? Fixed size is equals to 8,8. Okay, let's print it out, and once we have this, let's add the subplot over here. Okay, plot subplot of 1 comma first row 7 columns I plus 1. Okay, and plot dot image, and plot dot title as expression. Okay, and plot dot show, plot dot axis of, let's of the axis. Okay, and here I is equals to I plus 1. Okay, here we have an error. Anger, disgust, fear, neutral. Let's change this one. Okay, should be good. Yeah, so this is an angry image, and this is the disgusting, and this is fear, and this is happy, this is neutral, this is sad, and this is surprise. Okay, so 7 different emotions with respect to their images. Okay, now we are done with the data, and we have to load this data into, so here we have the expressions, right? 7 expressions and different types of images are there, and we had printed some images as well with respect to that emotion as well. Now let's load this into a arrays. Okay, data train data generator is equals to an image generator. Okay, and once we have this one, then we have to create the data, train data, right? Train data set is equals to train data gen dot, and what we are going to do is flow from directory. Okay, first thing we have to pass here is the path, training data path. Okay, and next thing is shuffle is equals to true, and target size of the images should be 48 pixel with 48 pixels height, and color mode is equals to grayscale, and class mode is equals to categorical color. 2 3 4 5, and I think we should be good. We can have the batch size as well if at all required. Okay, batch size is equals to 128. Okay, so all these images came into these places. Okay, now let's do the same for the validation data set as well. Okay, I'm just copy pasting to just save the time, and here instead of try we'll be having validation. Okay, data set, and yeah, validation data set, validation data set, and train will be having validation data path, and shuffle here is false, and everything looks same. Okay, so 7066 images belonging to 7 classes. Now we are done with this data augmentation. Now let's move on to the model creation. Okay, most important thing. So model is equals to model start sequential model. Okay, so once the model is created, we have to add the layers. Okay, let's add the first layer. Model dot add of, okay, layers dot, the first one we have to do is font 2D. Okay, count 2D 64 nodes, and kernel size is 3,3, and padding is equals to same, and activation is equals to relu, and input shape equals to 48 comma 48 comma 1. Okay, next model dot add layers dot batch normalization. Okay, and next one is model dot add of dropout. We have same activation relu, and we can have this layers dot, okay, max pooling 2D as well. Max pooling 2D, pole size is equals to 2,2. Can have this one layer as well. Now finally model dot add of dropout. To avoid the overfitting of our model, let's just add 0.25. Okay, so this is one layer. Okay, let's create similar layers. Layer 1, and this is going to be layer 2. Okay, and here instead of 64, let's have it as a 128, and we don't need this input shape. Okay, just removing them, and everything looks same, and let's change here kernel to size to 5,5. Okay, and let's have it as 256, and let's have 3,3, and here also same. Okay, and let's move on to the next one with the 512 nodes. Okay, 512. Okay, kernel size same, max pooling. Okay, now we are good. Now let's add another couple of layers of dense layers. Okay, model dot add of layers dot, let's flatten the data first. Okay, once the data flattening is done, going to add model dot add layers dot, and dense layer with the 128. Let's have it as 128, and it will be same. And here also model dot add of layers dot normalization, batch normalization, and here also model dot add of layers dot activation is equals to relu here also. And now model dot, let's add dropout to avoid the overfitting, dropout 0.25. okay, let's copy this entire thing and paste it here. 128, let's change it to 256, and yeah, everything looks same. And final model dot add of layers dot final one dense with the 7 outputs, right? Output is 7, and here activation is equals to softmax, because this is going to be an output, right? So that's the reason softmax it. Now let's print the summary of the model here. Model dot summary. Okay, here we forgot some comma. Model dot layers com2d. Seems like I have made a lot of typo mistakes, which I'm correcting here it now. Okay, uh, here as well. See, our model has been finally created. Okay, with all the layers. So first layer is com21 with the 48, 48, 64 input shape and max pooling as well, and then dropout. Then here with the 128 nodes. Okay, and third one with the 256 nodes, and fourth one is 512 nodes. And here finally we are flattening the data, and here dense layer with the 128 nodes, and dense layer with the 256 nodes, and finally none 7, which is the output softmax. Okay, now I'm going to compile our model, right? So model.compile is equal to compile, and here what I'm going to do is first thing optimizer, right? So optimizer is equals to Adam by default, and loss is equals to categorical cross entropy, okay. And what is the other one? Optimizer loss is there, and finally matrix. Okay, matrix equals to accuracy. Okay, okay, so our model compilation is done. Now we have to fit our model, right? So model dot fit training data path and validation data set is equals to, okay, not here, this one what we have used, we have used the data augmentation here, right? Okay, train data set, let's copy this one and oh, okay, val and score data set. Okay, and finally epochs is equals to 50 epochs, and anyways we have given batch size while creating there, but you can still pause here like 128, and verbose equals to 1. So you can press Ctrl plus Enter to fit our model with the training data set and validated data with the validation data set. But what I'm going to tell you here is this would be taking a lot of time for each and every epoch. On an average, it is taking 6 minutes in my laptop. So based upon the system configurations which you are running this code, it may take more time or it may take less time. Okay, if your configuration is too good, then it will take less time, and if your configuration is not that much great, then it will take a lot of time for you guys. So to reduce the duration of this video, I have already done all these things and I have saved the model in the same folder, project folder, which I have shown you guys here, right? See, face emotion classification.keras I have already created and already saved this model. So I'm going to use that model now, okay, to predict the features. When you are executing for the first time, please to execute this step as well, then only your model will be created. Okay, so I'm just skipping this step to just save the duration of the time. Okay, and let's import the model is equals to tf dot keras dot models dot load model, and I'm just going to previous folder. Yeah, this is one, copy path. Okay, pasting it here. Okay, the model is ready now. So once model is loaded, now it's time to predict the values from the model. Okay, first import cv2 to read our images. Image is equals to if you see here, there is a folder called Google Images where I have downloaded images from the Google. Okay, and image is equals to cv2 dot image. Right, let's read the image first. Let's copy this path. This is an angry set, right? Okay, once it is done, and what I'm going to do next is comma 1 comma 0. Okay, once we read the image, then we have to resize this image, okay, to 48 pixels, right? Resize image comma 48 pixels height and 48 pixels width, height and width. Okay, and image is equals to mp dot invert of np dot array of, okay, this image. Okay, now it's done. Okay, now let's predict from the model dot output is equals to model dot predict of what we are going to do is model predict of this image, right? So it's predicted, and np dot argmax of output, it's giving 0. What is mean by 0? We have to pass it to our emotions, right? Emotions of np dot argmax output. So it says it's angry. Can have rate of 0, angry. Okay, now let's take another image. Let's take happy image as well. Okay, copy path, and I'm just going to paste it here. Okay, it says happy, so our model is predicting properly. Okay, so let's take a look at what exactly we had done. Okay, so first things first, we have imported the basic libraries. One is numpy, matplotlib, pyplot for the to display the images. Next TensorFlow, and then TensorFlow image pre-processing libraries. Then Keras with the layers and models. Next we have two data sets. One is the training data set and the validation data set paths. Then we have imported the OS. Now we have listed the images with respect to the count of the number of images with respect to the human emotions. Okay, and same for the validation data set we had done. And once it is done, we have taken this emotions into a one array, okay, category array, and here we have displayed some images with respect to the human emotions, okay, angry, disgust, fear, happy, neutral, sad, and surprise. Next, what we have done is, here we have done is image generate data generator. So whatever the data which is there in directory, we are converting that image to the numpy arrays, numerical arrays, so that we can feed the data into our models. So this is for the training data set, and this is for the validation data set. So once we read the data from the directory to arrays, then we have to prepare the model. So here is the model. So the model which we have created here is sequential model with the multiple Keras layers. One is contour, batch normalization, max pooling, and dropout. 1 2 3 4 layers. Then we have flattened the data here. So then we have used the dense layer and then dropout for the not to fit the over model overfitting. Then we have used the finally dense layer with the 7 output nodes where activation is equals to softmax. Okay, here is the summary of our model. And yeah, model.compile optimizer is equals to Adam and loss is equals to cross categorical cross entropy and matrix is equals to accuracy. And here we have trained the model. I did not execute it properly in this video because it is taking a lot of time. So again, I'm suggesting you guys just do that. I'm not able to execute because to reduce the duration of this video. Okay. And here I have already done and I just did the same model. After executing this statement, I had saved this model and then I'm just reusing that model here now. Okay. And CV2, and then here we are reading the images from the Google, which we have placed it in the folder, and then our model started predicting the values. Okay. So now this is done. So the next thing what we are going to do is let's create a web application. Okay, as you guys seen the earlier part of this video. Okay, let's jump into the Visual Studio. Let's create the app.py. Okay, let's create the web application now. Let's import necessary libraries here. Import streamlit as st and import TensorFlow as tf, and from TensorFlow dot keras dot model keras import just models. Okay, and we have streamlit, import numpy as np, and import os, and import cv2. Okay, we have here model is equals to models dot load underscore model of, copy this path where this model is being saved. Yes, copy path. Okay, once we have the model, now st dot header human emotion recognition. Okay, human emotion recognition. Now st dot text input. Okay, where we are going to get the file path, right? Enter image path home. This is going to be the image. Okay, okay, saving it and going here. Here we have these things. Let's copy paste from here to here, and here instead of this one, what I'm going to do is image. Okay, and it will be done. And next thing is let's copy this category as well. Okay, emotions. Emotions is equals to this one. Okay, once we have the text input, we have passing it, and then we have to give it to model, right? Output is equals to model dot predict of what we have to pass, image, and whatever the output it comes, let's take the maximum of that one. Okay, and let's pass it here, and outcome is equals to emotions of output. Okay, and string is equals to emotion in the images is okay plus str of outcome, and st dot markdown of stn. Now we have to print this image, right? Let's get the base file name. Okay, image name is equals to os dot path dot base name of from total image path. Okay, let's pass this one to here, and here I'm going to pass this one. It will give you the file name. Okay, and st dot image of Google images slash plus this image name. Okay, and we would need width is equals to, okay, here we are importing the model, and then emotion categories, human emotion recognition. We are taking the image path, passing it here, and our model is predicting, and then we are printing it, and we are displaying the image. Okay, saving it. Let's run in a dedicated terminal. Let's hope there won't be any errors. Oh, somewhere none object type is not suspectable. Okay, this is fine, it will come. For now it is blank, right? Let's try streamlit run app.py. Okay, so here is the final project looks like. So here we have a folder called Google Images, and all these images are downloaded from the Google. Okay, and here the each and the name of this image says that the kind of emotion inside that image. Okay, let me copy it as a path and pass it as input to this text box here, and remove this double quotes. Okay, press enter. Our model is running. See, emotion in the image is angry. Okay, let's change a bit here. Image name outcome of 0. Okay, and let's always rerun. So here is the final project, how it looks. Human emotion recognition. Okay, here it takes the path. Okay, and here it is going to say that the kind of emotion in the inside the image, and here we are displaying the image as well. Okay, if you see here, there is a folder called Google Images where we have downloaded a couple of images from the Google, and the name of the image says that the kind of emotion inside the image. Here we have 4 images. One is angry, happy, sad, and surprised. And let's see how this model is going to predict the emotions, whether it is predicting properly or not. So first one is angry. Let's copy it as a path and then pass it here. Okay, and remove this double quotes, home, and delete, press enter. So it's angry. And next one is happy. Yeah, emotion is happy. And what else? The next one, sad. Okay, pass sad. Oh, sad. Emotion and the image is sad. Okay, it's predicting properly. Surprise. Surprise. It's treating it as an angry. Okay, because it seems like they're shouting, right? So that's the reason it is thinking it as an angry. So out of 4 images, I think our model has been predicted 1 image wrong, and remaining 3 it's predicting properly. This is how our final project looks like. If you like the content in this video, please do like and subscribe to our channel. Thanks for watching this video.